Hello student. In this lecture, we are going to go through the NoSQL databases and continuing with further on topic. So outline is for this lecture is NoSQL database. It is a very brief topic we will cover, and in last week we saw the problem with the traditional system, like the diverse data is there are RDBMS data is there, then there are subsidiary data in XML, JSON, flat file format, and that gave rise to the distributed file system and Hadoop kind of structure. Now, traditional system doesn't allow direct access to it. Then the app like Scoop came up, which task is just to get the data from the traditional system and feed it to the HDFS system. And then there are other kind of data for that. Flume provide the service. Flume is point-to-point system. Flume is still relevant. Then Kafka is there. Kafka is a message queuing kind of system, and Kafka can store by default for 7 days, while Flume doesn't store the data, it directly pushes the data. Then the Spark streaming came up, and then Flink, Storm, all these kind of services is there. If someone wants to develop something, then that new app can be used to do some kind of application on using these tools and Hadoop system. Hive is used to do the SQL kind of query on the Hadoop system. And we saw MapReduce, and Pig is there. Pig is not getting used anymore. Then there are other tools where they're like Impala, Hawk, Presto, Drill, Phoenix. These are all ecosystem for Hadoop, and then there are NoSQL database like HBase, which comes means by default Hadoop support HBase. HBase is a NoSQL database, and today we'll see what is this NoSQL database in short. We have also seen the yarn. So what this NoSQL database? NoSQL database is, as we know that with the need of the industry, the type of database started becoming non-relational. It's RDBMS cannot support, and RDBMS do provide a very good property, but the application in the present time we have that doesn't require that much requirement which RDBMS provides. So how to store this data, for example, the Amazon platform, and Amazon platform provides product. There are thousands of products are there, and if you go to any Amazon product, immediately you will see tons of informations are there, at least 50 to 500 different attributes it can have. And if you want to put it in a RDBMS format, it will be a large table. And like that, if you go to the not many product, millions of product, and this database size will be so big, and querying in the RDBMS will be very difficult. So what the present industry needs in most places, if they're not doing consistency transaction kind of thing, they want something to be processed faster, and something to be like, if you click the product and the page comes, it automatically comes. It doesn't take time, right? It comes just a fraction of a second, and you can see the product information, specification, the review comments, many pictures of the product, and many things, who is a seller, etc., and then also what other thing you can people have bought with this, like that kind of thing. And this kind of query, if we want to do in RDBMS kind of thing, it is going to take a long time. So what we are going to see is that the industry demanded NoSQL kind of database. And NoSQL kind of database can support all this kind of thing. And what it needs is that it is a present generation database system, which is not being relational, and the distributed processing is needed. Open source and horizontal scalability was a need. So there are basically 4 types of NoSQL database. One is a key value pair. An example is a DynamoDB. Other one is a document type, MongoDB. Then another NoSQL database is type is columnar, where the data are stored in a column, not in a row as a format. So HBase, which is supported by Hadoop, and Cassandra is there. Then there are database which are graph type. Neo4j was the first commercial graph NoSQL database platform. So what they do, they provide object database. They use a tuple store, and it can be hosted. There are multi-value database. There are multimodal database are there. So in the database world, apart from NoSQL database, there are object-oriented databases there. There are time series supporting database, like present day, lots of IoT devices are there, streaming devices are there, and that is a time series device. So those kind of device support streaming kind of device supported by for time series kind of databases schema. Welcome back, student. So we continue from here. So what is a key value database? So in key value basically is the simplest database where every single item in the database stored as a attribute with the name as key, and whatever its value is there, it is stored with as a value. For example, a product can be stored in a key value, like a product ID can be key, and every information related to product can be stored as a value, like its name, its manufacturer, its specification, its picture, its review comments, etc., etc. Everything can be stored as a value. Example of the key value database are React and Berkeley DB. There are other database, key value database are there. We will see later. And there are columnar databases are there. And Cassandra is a very good example, HBase and Cassandra, where data are stored as in a column format instead of row column format. And this is optimized for query, like for columnar kind of NoSQL database, we can do queries on the large data set. And for certain application, this kind of database really is useful, where the data is stored as a column together instead of rows. Then there are graph databases there, which is of NoSQL type, and where the information is stored as a network of the data. Mostly the social media company like Twitter use the graph database, and where each of the node or the key or the item is a node, and whatever relation with the other node is considered as an edge. And that is what you will see in the social media requirement. Then there are other databases like Fusikis are there, where triples are stored. Then there are document type of databases where data is stored in a document format, right? Complex data structure is there, it is stored in a document format. For NoSQL database, the requirement of a schema is not there, that you don't have to prepare a schema. Means there are some NoSQL database you can prepare a schema, but requirement the NoSQL database requirement of schema preparation is not there. So it is flexible. It can scale. It can become whatever you can do changes after creating it. So as you go, you can start building up the database. So what is a key value pair? So the key value basically is simplest NoSQL database, where let's say name is a key and the value is a joy block stored here. Another key can be age, value 42 is stored here. Usually the JSON kind of or block kind of file format is data is used to do a key value pair. It can store also string, and the key should be unique, and because key is the identifier and value can be anything. Examples are Redis, Dynamo, React. We will there are in the NoSQL world there are over 200 NoSQL databases are there, or vendors are there who are providing their own type of database. For example, if you mean by this like Redis, Dynamo, React, there are 3 NoSQL database. And like this, there are more than 200 NoSQL databases are there. And so it is not so, one does not need to know in so detail like we do in RDBMS about the NoSQL database. Like if you are joining any company, they will be preferably using only one kind of NoSQL database. What happened in the NoSQL database? NoSQL database is to store the data fast and fetch the data fast. The query and other consistency and other ACID property requirement like RDBMS is not needed, right? All the task of how you want to display, how you want to process is left to the application, which is actually seeking the data from NoSQL database. For example, if Amazon NoSQL database can have many information than what we see corresponding to our product. Like some product may not have the information which other product have, and it can choose not to display them and not to even see them. So the application layer is going to decide what to display and how to process it. While in SQL kind of thing, the query engine is going to do all the processing and give you the final output. Now, column database. Column database are basically, it stores the data in a column format. And example of database is HBase, Cassandra, Hypertable. Then column is stored like this. Column name is there, and then key value, key value, key value. Then column name, key value, key value, key value. Like this, column data is stored. Then comes the document kind of database, where it has a pair. It is basically a pair where key with the complex data structure are known as document. For example, this is a document kind of NoSQL database where document 1, property 1, the key data, key data, key data. Then key data, document 2, key data. So example is Amazon Simple DB, CouchDB, MongoDB. MongoDB is used by, there is a cab hailing or car hailing, very big company called Ola. That company uses MongoDB, and their requirement is they want to, so you have seen there are those car companies have at any point of time millions of users are accessing the app. And first of all, the requirement is that they want millions and millions of connection. So like MongoDB can give billions of simultaneous connections. So if a billion users want to access the database, the MongoDB is going to support it. So first of all, the requirement of this car hailing company is that the connection should not be a problem. Means every time a person opens the app, they should be able to connect to the database. And after that, the other requirement is that it should be able to see the car around. And that can be served by the MongoDB. And it doesn't have to be accurate, but the car, what is around, has to be shown and which place the person is. So the connection was more important than the accuracy and other thing, and MongoDB was supporting it. Over the time, this car hailing company, the performance and everything they have optimized, but in the beginning, the performance was not good. Later on, they actually shorted the performance in the application layer by improving the application layer. So the document-oriented NoSQL DB stores and retrieves the data in as a key value pair, and value part is stored as a document. So whatever the value is there, they are basically a document. A document is stored in JSON or XML format, and value is understood by the DB, and it can be queried also. Like if you want to say, if that car hailing example, like I logged into the app and I want to see, means it is going to know the GPS location of me and the other car which actually has registered with this app, their location. So it is going to query from this person within this view map area, how many cars are there. So it is simply going to, that can be queried and it can be displayed. So JSON formats are basically like this in the MongoDB. There's an object ID, which is a key, and then the type article, then all this information can be stored as a document. Like there's an object ID, this book, the author is Derek Rithans. Title is Guide to Date and Time Programming with PHP, ISBN number. So document description can vary. So this is an example of JSON format of MongoDB, document type of NoSQL database. Then comes the Graph DB. Then Graph DB is basically connections between the node and different node and edges which is connecting. For example, this person connection is like he's connected as a companion. This person connected to this person as a companion. This person loves this person and this lady loves the person. While this person is only a companion. This guy stole something from here and he is from this location. He has enemy and he appeared in this places and he also has enemy like this. So a kind of Doctor Who characters and relation can be stored in a graph DB like this. So graph type of database stores the entity as well as the relation among those entities. So city, person, restaurants are actually entities. So relation between them are stored as are known as edges. So entity is stored as a node, while the relationship as an edge. Edge gives relationship between the node, and every node and the edge has unique identifier. So both the node and the edge will have unique identifier. So you can see the person has many friends and he lives in this particular city. He also likes this C, and within the likes, ratings and reviews will be there. He likes this restaurant and he has given rating and review of the restaurants. and this restaurant is located in this city. So you see complex thing, and in the graph, query can be made. Like you can do a query in the graph database. Mostly the social network, like Twitter uses GraphDB. I think Neo4j is the database used by the Twitter. Then another graph DBs are Infinite Graph, OrientDB, FlockDB. So like this, over how many NoSQL database, internal or in detail, one can learn. So, and these are not complex. Majority of the tasks are actually handled in the application layer, and that is what people build. And learning the NoSQL database, knowing the basic concept of different kind of database is good enough to start working in those kind of database when the need arises. Some of the important database, NoSQL database are used. Most used databases are like Redis, CouchBase, MongoDB. Amazon has its own database, DynamoDB. IBM has Cloud, and Facebook has Cassandra. Then CouchDB, HBase. Azure has Cosmos DB, like Microsoft. Google Cloud Datastore, etc., etc., etc. So tons of databases there, and these databases means they are basically four kind of NoSQL database, like with a key value or columnar or document or graph. But why so many databases are there, and what is the difference between them? So this database has certain different database different company are providing. They are providing certain kind of services which actually making the business need, which is matching the need of that business of different company. So Redis is most used, and Redis is very fast. It has also caching memory. So some of the conceptual drawback which NoSQL database has, the Redis try to overcome it with different kind of architecture, and that's why people are using it. So all this database, practically four type, but internally they are providing different kind of services. For example, shoes, there are many company are selling the shoes, but shoes, or the task is we can wear it and we can walk and our feet are protected. And there are different kind of additional services can be there, like these are running shoes, these are snow shoes, these are hiking shoes, these are climbing shoes. But practically the task is to protect the feet. So there are so many databases are there. They have certain offerings which actually helping certain businesses matching their business needs. Now the NoSQL has a lot of feature and capability, like its performance is good. Certain NoSQL database availability is very high. We can do distributed database processing. Multimodal data can be used concurrently. Lots of people can get connected, like MongoDB can provide 1 billion simultaneous connection. Security is also good. Data can scale, and data model flexibility is there. Deployment model flexibility is there. So now, how many NoSQL databases are there, or database vendors are there? As per my knowledge, there are 225 when I searched for it. And now it can be more or it can be less, but more than 200 NoSQL databases are there. If you want to see how this NoSQL database world progressing, so you can see MongoDB is leading in the document kind of database, while columnar database, Cassandra and HBase is there, and key value pair, Redis database is there. Graph database, Neo4j is there, and their growth is until 2016 is quite uptrend. Now, what are the advantages of NoSQL database? So the advantages are that elastic scalability is there. because these databases are designed to be used with low-cost commodity hardware. That means the very sophisticated hardware needs are not there. The databases are actually designed for a distributed processing. So data are stored in a multiple location, and that location can be a very cheap commodity hardware. So if, as you know, these are being used in the Hadoop cluster or a cloud data cluster, right? Not for a single system. So where you have the few backup nodes like name node and data node, remember? So if one particular system where Spark, where this NoSQL data is running crashes, then it has another copy. So the aim is to minimize the cost of the hardware. So it supports that. It also supports big data application, right? It can handle massive volumes of data. And schemas are dynamic, that because we do not need to specify schema in the beginning with the data. It is compatible with cheap hardware clusters as the transaction data volume increases. So we can start with small, and as the volume increases, we can keep adding the commodity hardware. At a very low cost, we can store the data also. Another good thing it provides is auto sharding. So this is a particular functionality where it allows the NoSQL database to natively and automatically spread data across arbitrary number of servers, right? So means our business has NoSQL database. Let's say the Twitter has this. The Ola car has this MongoDB, right? Now that the number of users can start increasing. So once the system, the data may not be sufficient. So we need to add, so that data has to be kept in a multiple location, spread in a multiple location, divide and skip it. Now, auto sharding is a mechanism by which the database can be randomly stored into many servers without the need that application which is running on top of it. It does not need to know that how many servers are there, detail about it. So they will simply query or say, I want this data, and the system behind it is going to provide the data from it. So the location is not known to the application. It is the bottom, the below layer of the application, which is actually doing the resource management and other. They will be able to provide, okay, database, if this system you are accessing that crashes, okay, the copy is available in the other place, you do it. So application doesn't need to know. So this is called auto sharding. But there are disadvantages out there, right? So one of the big disadvantages of NoSQL database is it doesn't guarantee ACID property like RDBMS. Excuse me. So what is ACID property? ACID property is basically atomic. The transaction must perform in all or nothing manner. Means transaction must perform whatever query is given. All the task has to be performed, or none of the task has to be performed. So atomic. It's not that partly I did this and it's okay, not like that. So in ACID, atomic means all has to be performed. Then the consistent. The transaction must be processed in a uniform and a consistent way. For example, consistency means every user who is connected to the database must see the exactly same data. For example, there is Indian Railway is the second biggest or second largest rail network in the world, which has around 30 million daily passengers. Now, the Indian railway system is actually, earlier it used to use a traditional database, but now it is using the NoSQL database. So now due to which it can handle lot many people connection, and people just want to see where are the from this to this location, which trains are available and how many seats are available. Now, if it is a RDBMS system, then if it says that, okay, number of available seat is 10 to me, if anyone else has logged in the same time, he should be also be seeing that number of available seat is 10. But what the NoSQL database gives, that it gives you the connection, but it doesn't say the consistency is guaranteed. Like, okay, we saw the 10 and then we started booking it, and it can happen that the other person got the seat number something and I got say that waiting list. So there are waiting list concept is there. So if someone cancels the ticket, then the waiting list person can get it. So the one person got the ticket approved and I got the waiting list. So it is because of the data, the NoSQL database is not consistent, but people is able to connect it, and they are simultaneously can start booking and start entering the. So when the transaction step happen, that happen in a RDBMS system, but until the display showing the all the ease of booking the ticket and for this, it is on NoSQL database. Then it is isolated. So transaction must be appropriately isolated until they are complete. So if the query is given, those that searching in RDBMS has to be completely isolated unless it is completed. While NoSQL doesn't do these things. Now durable. So database management system must maintain a record of any incomplete transaction. Like if a particular, let's say, payment of a particular purchase is failed, that the database is not able to connect it or not able to write it, then a log has to be there that it's failed, so that recovery can be made if the failure can happen. But NoSQL database do provide some property. So you see ACID. So since NoSQL is not a SQL kind of thing, so they created base. So alternative to ACID in NoSQL is that base. So NoSQL support base, which is basically available, soft state, eventual consistency. That means availability is high, soft state, and eventual consistency. So they created an opposite of ACID and they name it this kind of property. So NoSQL has this kind of property. So with this, our NoSQL database lecture is over, and we take a break here for 5 minutes.